Okay, now you heard the user stories. We have the difficult task to make those user stories happen, which is difficult. So we suggest an architecture, but this is only a suggestion. There's many ways of doing such architectures, but as you've seen from Daniela Baumgärtel, those convene or they funnel into a point because the technology that we use makes sense in the context. This will be a slide film because I will switch slides quickly. In lack of time, 15 minutes to present complex systems is not much. Our 100 document page, Patrick, will be published this month. If you have questions, contact us afterward and use Slido because Staffan will look at it. He promised me. Okay, so our design goals were, if you look at the 500 million single market, you want to have a system that is extremely flexible, interoperable, combinable, extensible, and a standards-based level playing field. It must be product-centric and decentralized in all kinds of ways you can imagine. It is using, it's also integrating into existing data flows. That means when we talk about DPPs, we want to have an assembly of all kinds of data coming and being filtered to finally represent the DPP. That means we assume easy assembly of DPP data from existing sources. There I have just used the usual buzzwords here. It must be easy to create from those existing workflows, from a variety of sources, easy integration, but we also added a feature which means automatic validation. Automatic validation of your DPP, which allows you to kind of get comfortable and say, okay, our DPP is in line with the expectations that we set or that were set by rules, and we can sleep well. This can be, it would be really cool if the validation tools would be validated by the authorities to say, okay, your validation tools are in line. Of course, we need control, access control, usage control, compliance automation with secured logs and things like that. Basic features, public information for consumers. That means that must be totally easily a reliable discoverability, easy to display on any device, which means today you have to use web technologies, you have to use a browser. Flexibility, meaning we talk about a product-centric system, as we have learned, but delivering information really based on needs. A recycler needs different information than a consumer, and sorters need, again, different information and so on. But how to do that role-based and easily? And finally, public authorities have still different needs. They are rather data-centric, meaning they need to access the information before accessing or looking at the product. Extensibility means it must integrate into the data space concept. Where comes the data from? Into Gaia-X and the requirements into Gaia-X, non-mandatory data as an information system needs to be added easily, you know, out of the box, and ability to just integrate into Industry 4.0 data flow. That just should be easy. So what we are talking about is a decentralized interoperable basis for 1,000 flowers to bloom. To do that, we use web technologies and internet technologies because that's what everybody uses anyway for this kind of task. So how do we do that? So we have done one system, but two ways to access. That means the system itself goes always, I show it later, from a product UID to information, to the DPP information, DPP data. And we have two ways. One is an HTTP way, which uses URIs, a DNS system, a resolver, and the resolver points me then to a data storage. And we have a DID method, this DID method is using a DID distributed identifier, a method which contains a method. The method could be integrating in the European blockchain service infrastructure, but can also be a web method. That leads to a DID document. In the DID document, there is a pointer to my data. So those are two parallel things. The DPP data for both systems is the same. That means it's only the way from the product identifier on the product to the data that is different. The rest is the same. So here we have parallel but interoperable designs. The HTTP infrastructure is really short-term. It works out of the box today with high availability for tools, open source. It's still decentralized. We know about 5 roles, but it's a different path to the same information. And DID, we have included advanced features that are not really there out of the box, but very useful. And we have also the 5 roles, and we end up in the DPP data. Common is they are decentralized. DIDs are more decentralized. We are totally product-centric, meaning we start from the product UID and we try to discover the data, not the other way around. We have linked data as an interoperability layer. We have a decentralized data repository that can be split. That means this can be on one server or many servers. APIs are standardized because it's web technologies. There are 1,000 ways to implement all of this. This is not a specification. If you want to have a specification, we need to be much more detailed, and then there is one way, but the architecture carries more. And it has tailored access that I already mentioned. So this is how it looks like, but here, this is only a structural diagram. That means here you don't have data flows, but the data flows themselves, from the use cases that we heard just, every use case, there must be a path that satisfies the entire use case. So when you read a use case, then you would be able to run along a path on this diagram, and you always end up in the DPP data repository to get your DPP data and so on. So, and then we have the same thing as a DID infrastructure, which uses, and where when you look at it, we have a resolver there that redirects me to the data. And this resolver in the HTTP structure is then taken by the DID document, which leads to the DPP data. Okay, now, how does the data flow look like? I need to hurry up. DPP creation, I said it would be a slide film. So the DPP creation, so first of all, clear, somebody has to create a product UID, whether these are GTINs or something you make up, but it must be a universally unique ID. And that is put on a data carrier, and then the data carrier is then put on a product ID, because when we say product-centric, we must go from the product to the information. That means we need to discover the ID on the product. Now, when we issue this DPP, I put you this on the slides because you get the slides later on. I don't have to explain you in 2 minutes what this slide means. Is read it from the left to the right. From the left, you assemble the data. You assemble it into a DPP, you validate the DPP, and then you go to the process which says ingest data, where you provide data to all the APIs. and then you put it on the data store. So now using the DPP. Am I already 10 minutes?
No, take your time.
The simplified thing is consumer info. So consumer, everybody has those famous smartphones. So you put it on a QR code, and it should give you the data from the DPP repository. And this is very simplified. So you scan the product data, you go to the resolver, making a GET request, and then you go to the DPP repository, which should have been orange. But now, for the document, of course, we have done the complete set of all the data flows that are involved in this, which is more complicated. Now we have a simplified view on the circular economy operators, because they need privileged data. We need something that I show you later, is there we scan the product ID, we go to the resolver. In the resolver, we send to the resolver a so-called typed link, which says, I'm a recycler, give me the recycler information. That goes to a policy decision point, because that may be even privileged information that is under access control or usage control. Having a credential that I give them, they say, okay, your credential is okay, you go to the DPP data repository, and then you get structured data. You don't get any HTML or PDF file, you just get structured database data that you can immediately reuse in your system, that goes into a recycling machine and such. So, but of course you need an identity management system in order to govern your policy decision point. So, in fact, it's a bit more complicated than that. So this is really this, and we have to note that the circular economy operator will have to use a dedicated app. Whether this sits on his sorting machine, or whether somebody stands there with a mobile phone and does manual sorting, we don't care. They can do both of it. It's just a front end. But we need a dedicated application, because this application will not receive any HTML. It will receive structured data. It will have to issue a very clear requests about roles and about queries and things. So it's more complicated, but it allows us to industrialize the recycling process. And then the big orange barrel at the bottom, we talk in CIRPASS always about the big orange barrel, which is the data repository. In the architecture, this is the endpoint, but it is the starting point of all our problems, because the big orange barrel needs to be a data space where many people feed data into, where we need to kind of aggregate data from supply chains, where we need to filter data, sort data, have rights expressed on data, have provenance data, data quality considerations, and so on. And then it is a concept. That means this can be 10 servers, 4 services that are orchestrated. It can shoot TLS and JSON-LD to one factory, but administration shell to another factory. It's just a matter of transforms. Okay. Concluding, we have an internet and web-based system. This internet and web-based is your standard level playing field. This is on top. There is no patents involved. This is what everyone uses every day, meaning we know how to do it. It's flexible and highly interoperable, but of course the interoperability has limitations when you go too large. It's combinable. All nodes can be services. You can have 10 nodes in one service or 10 nodes in 10 services. It is there to assemble data from a variety of sources so it can be merged. And it's extensible, so it can integrate into the EU data strategy, which is driving all the things we do right now. I think 4, 3, 1, 0. Thanks.
15 minutes exactly. Can we just introduce What's the following video?
And while we are at it, the next film is from Staffan, also from GS1, who has implemented such a system, this architecture, and he has shown how easy it is because it's just using web technology. It's a simple version, but it really shows how easy it is.
Hi and welcome. I'm Staffan Olsson with GS1 Sweden. The purpose of this video is to briefly introduce the concepts of resolvers and typed links, which are both widely used concepts in web technology, and explore how they might be used in the design of the DPP system. During 2023, a demo prototype for DPP called Prepare was built by some stakeholders in Sweden. This involved Swedish Commerce, which is a retail industry association. It also involved Ecolabelling Sweden, which is the issuer of the Nordic Swan Ecolabel and also the EU Ecolabel for Sweden and the Nordics. It involved GS1 Sweden, and it also involved Axe Foundation, which is a sustainability do tank, which are involved in projects like this. The focus of this project was on the DPP system and not on the DPP content. So the idea was to verify that a working infrastructure for DPP, compliant with the draft ESPR of the time, could be established, built on existing web technologies and GS1 standards. The project used products from the 3 brand owners you see on the slide. For each of the products, the project involved pulling data from 2 different data sources. First, from the brand owner for general product data, and also we pulled data from the Ecolabel organization for verification of the product certification status. So if you try it out, you can find the information on their website there. You will see that the prototype offers a very simplistic view of what a DPP could look like. And most of the interesting parts are actually invisible to the DPP user. So the products used in the demo are identified at model level with GTINs, which is the GS1 standard for product identification at model level. The GTIN, or Global Trade Item Number, GTINs are embedded in a web address in a QR code according to the GS1 Digital Link standard. This web address leads to a resolver capable of redirecting queries to 1 or more data sources using typed links. So here we use 2 link types, product information link type and a certification information link type. So I'll show you how this works. So a dedicated app is installed on a smartphone. With this app, you scan a QR code on the product. And when scanning that, it uses the link in the QR code to make a request to the resolver, asking for all known links associated with that GTIN. The resolver responds back with the links it has, indicating the link type for each link. So in our demo, this response returns 3 links. So first, it's the default link to the human-readable default page. It's also a link to machine-readable certification information, and it's also a link to machine-readable product information page. And you see on the left there how the response from the resolver looks like. The app uses the links to get machine-readable data from the 2 sources. The data at those sources is encoded in JSON-LD format according to the GS1 web vocabulary. So the app processes the data and presents it to the user. So I will now show you what it looks like in the app itself. So I have my mobile phone out. I open the app. It has a big button in the middle, says scan QR code. So I press that button and I have a product here. One of the products has a QR code on it. So it scans the QR code, gets the data. First, what is shown here is from the brand owner, which is, collected the way I described it with the slide previously, and also from the certification company that has shared the data about the certification status about this product. In addition, you remember there was a third link, the default link. So for users that don't have this app installed, they can just scan with a native camera app on the phone. So I'll try and do that. And this brings me to the regular brand owner website and the product page for this product. So that's how it's worked with link types. So what did we learn in this project? Well, thanks to this prototype, we learned a number of important lessons. First, we learned that the data flow works as expected. So that was a good thing. Secondly, building the app, we realized was fairly easy for an IT company since they used common web technologies that they already knew about. Thirdly, setting up the resolver was done fairly easily because we used open source software for this, so we didn't have to start from scratch. Finally, the machine-readable data was made available by the participants' brand owners and also the certification companies' internal IT resources, and they claim it was easier than they expected. So they needed between 4 hours and 1 week to make the necessary changes. And the one that needed a full week, they actually made a full integration with their backend ERP system to populate this data. So it actually comes from the real source in their company. Thank you for watching.